In this video, we'll discuss the variance in predictions resulting from a bivariate regression model. If we estimate a model, we can generate forecasts from that, where we plug in different values of disposable income, say, into this consumption function, and we get a predicted value of consumption. This equation gives us the variance of the forecast. It tells us how reliable that forecast would be. And think about how the variance of the forecast will change depending on things like the magnitude of sigma squared, the size of the sample, as well as the magnitude of the deviations of x from its mean, and see if those might relate to the types of things that might affect the variance of our estimators, and think about why. In general, we can say that forecasts have lower variance when the variance of the error term is smaller. In other words, if the equation fits the data better and there's less variance around the regression. It also gives you a lower variance if you have a larger sample. We can see that because the last two terms on the right will tend to get smaller when there's more observations, or if x is close to the sample mean. And to see why that's important, algebraically, it has to occur because of that 30 term in brackets. But here's the issue. In general, the sample mean tends to be a pretty reliable estimator of the population mean. But if you overestimate or underestimate the slope and the intercept slightly at the sample means, you probably still have a pretty good estimate. But the further you get away from x bar and y bar, the further your true relationship will be from the relationship you estimate. So in other words, you're able to get better predictions of outcomes from a regression equation when you have predictions that are close to the average value that you observe. The further you're trying to predict outside of the range in which you observe your data, the further away from the means that you try to predict things, the less reliable or the higher the variance of the forecast.